All right, everybody, welcome to Angles and Ratios Lesson 6. This is our last lesson of our first trig unit, and we are looking at building and using the unit circle. So this is just the same information that we used to build the reference chart, but now we are going to put it into a circle. And it's really nice because, it's going to work out really well because all of the hypotenuses are 1, and we know if that's the radius, that the radius has to be the same everywhere on the circle. So we can start to develop the circle. They're going to develop just a quarter of the circle. We're going to use these three triangles up here. I'm going to zoom in, so we're not going to see them, but you can use them as a reference because you'll be looking at the entire page. So I'm just going to zoom in here. So here is our unit circle. And we've got those three triangles drawn here. You can see the 30-degree triangle, just so that you can see it. The 30-degree triangle is drawn like that. The 45-degree triangle is drawn like that. And the 60-degree triangle is drawn like that. And because they all have a radius of 1, it creates a bit of a circle. And obviously we have 0 degrees down here and 90 degrees up here. We looked at all of those in the last couple of units. So it says, write the lengths of the horizontal and vertical segments. So we know if the x value of the 60 degrees is 1/2, they've already done that one for us. I'm just going to get rid of all that. The x value for the 45-degree triangle, which is this one right here, is root 2 over 2, and I'm taking that from up here, 45-degree triangle. The x value is root 2 over 2. And we can do the same thing with the 60, or we've already done the 60. We're going to do the same thing with the 30. So the x value of the root 30 is going to, the x value of the 30 is going to be root 3 over 2. We can do the same thing for the vertical line segments here. So the y value for the 30-degree reference triangle is 1/2, and then we've got root 2 over 2, and then root 3 over 2. And we can write the coordinates for all of these. So obviously for the first one, which is right down here, the x-coordinate, the x-coordinate is just going to be the radius, which is 1, and the y-coordinate is 0, because we are still on the x-axis. And the same for the 90-degree triangle, or the 90-degree point up here. In this case, we haven't left the y-axis, so our x value is 0, and our y value is 1. In between, we are going to use a combination of the 30 is going to be, our xy point, right? This is going to be xy, is going to be this value here and this value here. So that should give us root 3 over 2 and 1 over 2. Same thing, but with the 45. So now we're going to be using this one over this one, or this one and that one. Sorry, we're not dividing them. So it's going to be root 2 over 2 and root 2 over 2. And last but not least, we are using this one and that one as our xy coordinate. We already have the x in there. The y becomes root 3 over 2. So we've written the coordinates. We've done the line segments. How do the coordinates of the points relate to the measure of the rotation angles? So we learned this in the last lesson. For a rotation angle, theta, we know that x is cos theta and y is sine theta. So we could say that our coordinates xy are equal to cos theta sine theta. And we can take this circle and we can draw, we can kind of flip it so that we get this side as well as this side as well as this side. And I'll show you on the next page here. The unit circle, ta-da! So you can see in quadrant 1, we have a positive x value and a positive y value. In quadrant 2, we have a negative x value and a positive y value. But the values are the same. So you can see here for this point and this point, it's positive 1/2, positive root 3 over 2. But if we flip to quadrant 2, it's going to be negative 1/2, positive root 3 over 2, because the x value is a negative value, right? This is our x and y coordinates here. So if we go towards the left, we're getting a negative x value. You don't have to write on this, I'm just scribbling all over it. And then we know that in the third quadrant, we're going to have a negative x, negative y. And then in the fourth quadrant, we're going to have a positive x and a negative y value. So you only really need to memorize one quadrant of this, because the rest of it is the same with just putting your negatives and positives appropriately, which is really nice. So the circle above all has a radius of 1. So all of these measures from here to here or here to here or even there, those are going to be a radius of 1. And that's important because we know that if in sine of theta is equal to y over r, but r is 1, that means sine of theta is just equal to y. And same thing with cos theta, right? It's x over r, but r is 1. So that means cos of theta is just x. So every point on the circle has coordinate x, y, but we can write that as cos theta sine theta, which we did on the previous page. And we also know that tan is always sine theta over cos theta, if you're ever unsure. So let's use the unit circle. Keep your unit circle page open. I'm going to scroll down to the questions, but you're going to need the unit circle to determine the answers. So it says here, use the unit circle to find the exact value of the trigonometric ratios for the rotation angle of 240. So if you go to 240 on your unit circle, which is this one right here, right? That's 240. And we're looking for sine. Well, we know sine is equal to the y value. So the y value of that is negative root 3 over 2. So my answer becomes negative root 3 over 2. The cos of 240, well, we know cos of theta is equal to the x value. So the x value of the 240 is negative 1/2. And the tan is going to be equal to the sine of 240 over the cos of 240. And we know that's going to be negative root 3 over 2, all divided by negative 1/2. And hopefully you remember that when we divide fractions, we can do the keep, switch, flip. So that can be the same as negative root 3 over 2 multiplied, and then I flip those last ones to be negative 2 over 1. Negative times a negative will create a positive answer. And then you have 2 over 2 that cancels. So we're just left with root 3 over 1 or root 3. Use the unit circle to find the exact value of cos of 135. Cos of 135. So go to 135 on your unit circle, and we know we're looking for cos, we're looking for the y value, x value, x value. And that will be equal to, the x value is negative root 2 over 2. The tan of 122, so we know tan is going to be the same as sine 120, tan of 120, sorry, not 122. I don't know what's going on with my brain lately. Over the cos of 120. So in this case, the sine of 120 is the y value over the x value. So in this case of 120, it's going to be root 3 over 2 all divided by negative 1 over 2. So we're going to keep switch flip. Root 3 over 2 multiplied by negative 2 over 1. Positive times a negative will give us a negative value. And 2 over 2 cancels, so we're left with negative root 3 over 1, or just negative root 3. Sine of 180. Well, we know the sine is the y value, and 180 is just going to give us 0. The y value of 180 is 0. And tan of 270, well, that's going to be sine of 270 over cos of 270. And we know sine of 270, or the y value is negative 1. The x value is 0. So in this case, we are undefined. You cannot divide by 0. Okay, I just have a few more examples. All right, we have point A and point B are 2 points on the unit circle. If an object rotates counterclockwise from point A to point B, through what angle has it rotated? Well, here's our coordinate system. Point A is negative root 2 over 2 and root 2 over 2. And you can see that gives us 135. So that's going to be right there. And that is 135. Point B is negative 1/2, negative 3 over root 3 over 2. And that's going to give us this angle down here, if we look on our unit circle, of 210. So now we're looking for, if an object goes from B to A, how far has it gone? So we're going from here to here. So all we have to do is go, is it 240? Did I mess that up? It's 240. I lied. I misread my table. So now we're going from 240 to 135. So that means we've rotated a total of 105 degrees. Use a calculator to determine to 4 decimal places the coordinates of the point on the unit circle that corresponds to a rotation of 148. So this is where we're going to use, hopefully you remember, we're looking for coordinates. We're looking for x, y. And we remember that that is the same as cos theta sine theta. And we can actually just type that in. Cos 148 sine 148. And that equals, cos of 148 is negative 0.8480. And sine of 148 is 0.5299. That's your final answer. So use a calculator to determine to 4 decimal places the coordinates. Sometimes it's hard to figure out what they're asking, but if you're looking to 4 decimal places, that's going to be obviously a decimal answer, and that's how we go about it. This time they're going to give us the opposite. They're going to give us the coordinates, and we want to find the angle. So determine the value of theta, where theta is the angle made by the positive x-axis and the line passing through T. So that's the reference angle, right? From the positive x to the line pass. Oh, that's the rotation angle. Sorry, that's the rotation angle. So in this case, we have a negative x. Sorry, hang on. Let's do negative x, positive y. And if you remember, if we go back to our unit circle, negative x, positive y is quadrant 2. So we know we're dealing with quadrant 2. And we know that xy is the same as cos theta. So we know cos theta is negative 0.8829. And sine theta is 0.4695. Hang on a sec, someone's at the door. I don't know how to pause. Pause. Oh no. Okay, I don't know. I don't want to make 2 videos. Hang on, I'm gonna try to pause this. Nobody panic. All right, sorry, I'm back. That was a little bit weird, but I learned how to pause things, so that's pretty cool. Usually, I just have to make the video straight through, and if somebody walks in, I have to restart, which totally sucks. So that was big. Okay, where were we? Okay, here we go. So we had this point. We know that cos is our x and sine is our y. We know that. And we know also that add sugar to coffee. We're in quadrant 2, so we're over here somewhere. And we know that sine is positive, but cos is negative. So we can use either one of these to figure out our reference angle. So what we're going to do, sorry, that's an arrow. We can do inverse sine of 0.4695, and we will get 28 degrees. We can also do inverse cos, but you have to be careful with cos because cos is going to be negative in our second quadrant, or quadrant 2. So you just want to take the positive value of that. That negative is determined by the quadrant, and that will also give you 28 degrees. So now if we know the reference angle is 28 degrees, then we know that the rotation angle, the one they're looking for, is going to be 180 minus 28 degrees, and we get 152. That one got a little messy, I'm sorry. All right, so now we have 2 methods for determining exact values of trigonomic ratios of certain angles greater than 90. Use either method. Yay. A couple more examples. Use the chart or unit circle to find the exact value of cos 300 plus sine 330. So if we look on our handy dandy chart, we know that cos is x, sine is the y value. So cos of 300 is going to be 1/2. Sine of 330 is going to be negative 1/2. 1/2 plus negative 1/2 is 0. So now we have sine squared of 225 plus cos squared of 225. Got to be careful. It's both of these are squared. So what that means is we're going to find the value of sine 225. We know sine's the y value, cos is the x. So the y value of 225 on our unit circle is root 2. Wait, 1 second. Why is it negative? Mine is positive. Did they make a little error here? Sine is the y value. They both can't be negative. One's got to be positive. Either way. The answer comes out the same. Root 2 over 2, and because it's squared, we are going to square it. Plus the x value, which is negative root 2 over 2 squared. So we remember that this is going to act on both terms in there. So root 2 squared. So squaring something and square rooting it they're like opposite. So nothing ends up happening. The top stays as 2, and 2 squared on the bottom is 4. Same with this, except for the fact that when we square a negative, it's negative root 2 multiplied by negative root 2, which gets us positive 2. So squaring a negative just gets rid of the negative and turns it into a positive, and then the bottom is 4. So 2 over 4 plus 2 over 4 is the same as 4 over 4, or obviously just 1. All right. 2 multiplied by tan of 150 divided by 1 minus tan squared of 150. So that is going to be 2, and then tan of 150. So if we use our chart or our unit circle, we are going to find that that is equal to negative root 3 over 3. And that's all divided by 1 minus. And then be careful, this one's squared again. So we know tan of 150 is negative root 3 over 3, and that's all squared. All right, so hopefully we have room. The top becomes negative 2 root 3 over 3, and the bottom becomes, well, off to the side we can do negative root 3. It's squared, so it's going to be multiplied by negative root 3 over 3. Negative root 3 times negative root 3 is just positive 3, and 3 multiplied by 3 is 9, and that reduces to 1/3. So now we have 1 minus 1/3, and we know we can rewrite 1 as 3 over 3. So now we have negative 2 root 3 over 3 over 2/3. When we divide two fractions, we flip and multiply. I'm running out of space. Hopefully you have space. I apologize. I didn't realize it was going to take up this much space. So that becomes negative 2 root 3 over 3, and we're going to flip and multiply. So we flip to 3 over 2, and you can see that 3 over 3 cancels, 2 over 2 cancels, and the answer is negative root 3. Those ones are kind of fun. All right, that's the end of our unit. Sorry for the interruption in the middle. Hopefully it just blips ahead, but I don't know. I've never paused before, so we'll figure that out. Thanks for watching. Don't forget to like and subscribe.